Hello friends, today I am going to discuss about Apache Kafka, a widely used tool for processing of data in motion. Kafka is a distributed event streaming platform that allows us read, write, store and process events across several machines. Events are also called records or messages. Examples of events are payment transactions, geolocation updates from mobile devices, shipping orders, sensor measurement from IoT devices or medical equipment. And there are several examples of events. These events are organized and stored in topics. A topic is similar to a folder in a file system, and the events are similar to files in folders. Kafka was originally developed by LinkedIn to track website activities. Kafka is generally deployed for building real-time data pipelines and streaming apps. Kafka is being used due to several reasons. First reason is scalability. Scalability is nothing but number of messages sent per second in the system. Kafka can send millions of messages in a second. Second reason is persistency. The ability to recover messages is known as persistency. Kafka can provide data persistency. Third reason is consumer capability. Kafka supports one-to-one as well as one-to-many consumers. Now next reason is performance. Kafka is very fast. It can process millions of messages per second. Now next reason is flexibility. Kafka is designed to interface with several variety of the systems. Availability. Kafka provides high availability through load balancing and data replication. Next reason is strong reputation. Kafka is used by leading companies, high-profile organizations such as LinkedIn, Netflix, Twitter, Spotify, Uber, and many others. Kafka supports all major languages such as Python, Java, C, C++, Clojure, .NET, PHP, Ruby, JavaScript, Go, Swift, and many more. Kafka is among the top 5 most active projects of Apache Software Foundation. Now come to the Kafka architecture. Kafka consists of several components such as producer, consumer, clusters, brokers, zookeepers, topics, and partitions. The job of producer is to send records to the cluster, which stores those records and then pass them to the consumers. Consumers, by using partition offset, the Kafka consumer maintains how many messages have been consumed. Clusters, to maintain load balances, Kafka clusters consist of multiple brokers. Brokers, each server nodes in the cluster is a broker. It stores data provided by producer until it is read by consumer. Zookeeper, Kafka brokers uses zookeepers in order to manage and organize tasks. Topics, the topic is a logical channel to which producer publish messages and from which the consumer receive messages. Now come to the partition. In a Kafka cluster, topics are splitted into partitions and also replicated across brokers. How to use Kafka? There are following steps. First, get Kafka installed as per operating system like Windows or Linux. Second step is start the Kafka environment, run Kafka server and Zookeeper server. Step 3, create a topic to store events. Fourth step is write some event into the topic. A Kafka client such as Kafka producer or consumer, they communicate with the Kafka broker via network for writing or reading events. Once received, the broker will store event in a durable and fault tolerant manner for as long as we need. Even forever we can store the events. Step 5, read the events. Since events are durably stored in Kafka, they can be read several times and can be used by several consumers. Step 6, we can export data as stream of events with Kafka Connect. Kafka Connect is a tool. Step 7, process events with Kafka streams. Once our data is stored in Kafka as event, they can be processed data with Kafka streams client library supported by Java and Scala. Now come to the Kafka use cases. Some of the best Kafka use cases are: number 1, high throughput activity tracking. For example, we can use Kafka to track website activities, capture data from IoT sensors, monitor patients in hospital facilities, or keeping track of shipments. Second use case is stream processing. For example, in an IoT application that consists of automated thermometers, we can keep track of average temperature over a time and trigger alert if reading deviates from a target temperature range. Third use case is event sourcing. For example, we can use Kafka with a banking application. If account balance is somehow corrupt, we can recalculate the balance based on stored history of transactions. Fourth use case is log aggregation. We can use Kafka to collect log files and store them in a centralized place. Thank you so much. Please like, share and subscribe my channel. Thank you so much.